Hello students, today we study about stable and unstable equilibrium of a dipole. We know when we place the dipole in a uniform electric field, the dipole experiences equal and opposite forces. So the net force on the dipole is zero, but it experiences the torque. This torque tries to align the dipole in the direction of the electric field, and this torque equal to P sine theta. Theta is the angle between the dipole moment and the electric field. We know this torque is 0 when theta is equal to 0 degree and at 180 degree. At these two positions, the dipole is in equilibrium position. And at 0 degree, we know the dipole is perfectly aligned along the direction of the electric field, means the dipole moment is parallel to the electric field, so no torque acting on the dipole. In this case, the dipole is said to be in stable equilibrium position. So what is stable equilibrium position? When the dipole is perfectly aligned along the direction of the electric field, the dipole moment is parallel to the electric field, no torque acting on the dipole, is known as the stable equilibrium position of the dipole. Why it is called stable equilibrium? Because when we disturb the dipole slightly from its equilibrium position, it will rotate back towards equilibrium position. That is why it is called stable equilibrium position. Example, here we displace the dipole slightly in the anti-clockwise direction, but the torque acts in the clockwise direction, so the dipole rotate back towards equilibrium position. That is, the dipole again aligned along the direction of the electric field. That is why it is called stable equilibrium position. But when theta equal to 180 degree, the dipole is aligned opposite to the direction of the electric field. In this case, the dipole moment is anti-parallel to the electric field. So when we disturb the dipole from its equilibrium position, in this case, it will not rotate back towards equilibrium position. Example, here we disturb the dipole, we displace slightly in the anti-clockwise direction. Torque also acts in the anti-clockwise direction, and the torque tries to align the dipole in the direction of the electric field. Here the dipole not rotate back towards equilibrium position. That is why it is called unstable equilibrium.